أعزائي الطلبة، السلام عليكم ورحمة الله وبركاته. أهلا بكم في درس جديد من دروس Statics. درسنا النهاردة بنتكلم فيه على الفورسز، وأول حاجة بنتكلم على definition of the force. Definition 1. Force is defined as the effect of a natural body upon another one. The effect of any force depends on the following factors. We have three factors. The first factor is the magnitude of a force, and we can measure it using the units of forces like Newton or dyne or kilogram weight. Second, direction of the force. Third, point of action of the force and its line of action, as we will see in the following examples. But first, we must know the resultant of two forces acting on one point. If we have a parallelogram OACB and the force F1 acts on the side OA and the force F2 acts on the side OB. Note that OA and OB are two adjacent sides on the parallelogram. Then R will be represented by the line segment OC, such that OC is the diagonal in this parallelogram. So we can say R is represented by the diagonal of the parallelogram OC. So we have R equals F1 plus F2. R is a vector. The three forces here are the resultant, and the first force and the second force are three vectors. So R equals F1 plus F2. Note that the line segment OA plus line segment OB not equal the line segment OC. But F1 as a force plus F2 as a force equals R as a force. The three forces are vectors, and this is the parallelogram rule to add the two forces. The parallelogram rule to add two forces. F1 plus F2 equals R. Example. F1 and F2 are two forces at a point on a rigid body where F1 equals 300 Newton acts in the direction of east. F2 equals, the force F2 equals 400 Newton acts in direction 60 northwest. Find their resultant. Now we will discuss the solution with steps. First, choose a suitable drawing scale, 1 centimeter for each 100 Newton. So F1 will represent by a line segment of length 3 centimeters, because the drawing scale is 1 centimeter for each 100 Newton. We have here 300 Newton. So F1 were represented by a line segment of length 3 centimeters. And we draw OA to represent the force F1, such that the norm of OA, the length of OA equals 3 centimeters in the positive direction of the x-axis. So this OA represent F1. and we draw OB to represent the force F2 such that OB, the norm of OB, the length of OB equals 4 centimeters in the direction, here is OB, in the direction 60 northwest. So this angle, the angle between OB and the west equals 60 degrees. So the angle between OB and OA is 120 degrees. So measure of angle AOB equals 120. Measure of angle AOB equal 120 degrees. Note that the sum of 120 plus 60 equals 180. And don't forget that the drawing scale is 1 centimeter for each 100 Newton. We have 400 Newton, so we represent it by a line segment of length 4 centimeters. The norm of the vector OB, its length, its norm equals 4 centimeters. Since the measure of angle, the angle between OA and the west is 60 degrees, then the measure of angle BOA equals 120 meters. Then we complete the parallelogram OACB. We'll complete this parallelogram. Now we have parallelogram OACB, and we have the two forces OA and OB. Then the diagonal OC represents the resultant of, so the resultant represented by OC, by the vector OC, and the norm of OC equals 3.6 centimeters. We will measure it using ruler. So the norm of the vector OC equals approximately 3.6 centimeters. We will measure it. And R of magnitude 3.6 multiply the drawing scale, multiply 100. So R equals approximately 360 Newton. And this is the magnitude of the resultant of these two forces, F1 and F2. And R makes an angle of inclination 73 degrees 53 minutes 53 seconds with the direction of F1. The measure of angle AOC equals 73 degrees 53 minutes 53 seconds. And this is the solution for this problem. The resultant of two forces meeting at a point analytically. If we have the two forces F1 and F2 represented by the two sides of the parallelogram OA and OB, and the angle between F1 and F2 of measure alpha, we know that OC represent the resultant, and the angle between the resultant and OA equals theta. So let F1 and F2 be two forces acting at O. Alpha is the angle between their directions. F1 and F2 represented by OA and OB. R is represented by OC. It is the diagonal of the parallelogram. Let theta be the angle between R and F1. Theta, here is the black angle. It is the angle between OA and OC. The angle between F1's first force and the resultant. Using the cosine rule. Cosine rule here, if we have the triangle ABC, the length of CB is A, small a, and the length of AB equals C, AB opposite to the angle C. And we assume that B is the length of AC, such that AC opposite to the angle B. We know that A square equals B square plus C square minus 2BC cosine A. Minus 2BC cosine A. The length of A square, the length of CB square equals the square of the length of AC, the square of the length of AB, minus 2 multiplies the product of AC and AB, multiply cosine the included angle between them, cosine A. Back to the forces. R equals square root of F1 square plus F2 square plus 2 F1 F2 cosine alpha, and we'll prove it. Tan theta. Theta is the inclination angle of R with the first force. So tan theta equals F2 sine alpha over F1 plus F2 cosine alpha. Again, theta is the inclination angle between the resultant and F1 and we'll prove it. We'll complete the figure, adding some information on it. If the angle BOA, this angle equal alpha, then the measure of angle CAE equals alpha, as OB parallel to AC. So measure of angle CAE equals the measure of angle BOA because they are in corresponding position. If measure of angle CAE equals alpha, then the measure of angle CAO equals 180 minus alpha. This angle equals 180 minus alpha. OB represents F2, then and the AC parallel to OB. Then we can transfer F2 to the side AC. Now look to the triangle OAC. We can say that OC square equals OA square plus AC square minus 2OA dot AC cosine 180 minus alpha. Again, according to cosine rule, OC square equals OA square plus the length of AC squared minus 2 OA dot AC multiply cosine the included angle, cosine 180 minus alpha. OC square equals OA square plus AC square plus 2 OA dot AC cosine alpha. Note that cosine 180 minus alpha equals negative cosine alpha. Negative multiply negative equal positive. cosine alpha. Again, cosine 180 minus alpha equals negative cosine alpha. So we substitute cosine 180 minus alpha by negative cosine alpha. Negative multiply negative equal positive. Positive cosine alpha. Since OC square equals OA square plus AC squared plus 2OA AC cosine alpha, then we can substitute by R and F1 and F2. So we have R square equals F1 square plus F2 square plus 2F1 F2 cosine alpha. Then R equals square root of F1 square plus F2 square plus 2F1 F2 cosine alpha. Now we will complete to calculate tan theta, the direction of the resultant with respect to F1. Look to the triangle OEC. Triangle OEC. You note that tan theta equals EC, the opposite, over adjacent over OE. Again, tan theta equals EC over EO. Opposite over adjacent. What's the length of EC? The length of AC is F2 sine alpha. The length of AC is F2, right? And this angle equal alpha, and the AC opposite to the angle of measure alpha here. So AC equals the hypotenuse of the triangle AEC of length F2 multiply sine alpha. Also AE equals the hypotenuse of this triangle of length FE cosine alpha. So we can write tan theta equals CE over OE. CE over OE. CE over OE. OE equals OA plus AE. Look to the figure. OA plus AE, that is the length of OE. And we substitute CE equals F2 sine alpha. OA F1 plus AE, it is F2 cosine alpha. So this is the proof that tan theta equals F2 sine alpha over F1 plus F2 cosine alpha. And don't forget, theta is the included angle between the resultant and the first angle. Here always the first force. The first force F1, it is the first force. So the angle between the resultant R and F1, it is theta. Okay, let us solve some problems to use these rules. Example, two forces of magnitude 3 and 3 root 2 Newton act on a particle, and the measure of angle between their lines of action is 45. F2 equals 3 root 2 Newton, F1 equals 3 Newton, and the angle here equals 45. Find the magnitude of their resultant and the measure of its inclination angle with the first force, with F1. Solution: let F1 equal 3, F2 equal 3 root 2 according to the given and the figure. Alpha, it is the angle between them, it is 45. Since R equals the square root of F1 square plus F2 square plus 2F1 F2 cosine alpha, and we substitute r equals square root of f1 equal 3, so we have 3 square, f2 equals 3 root 2, so we have 3 root 2 square plus 2 multiply f1 plus 2 multiply 3 multiply 3 root 2 cosine 45. Using your calculator, you will get r equals 3 root 5, and tan theta equals f2 sine alpha over f1 plus f2 cosine alpha. Tan theta equals 3 root 2 multiply sine 45. 45, it is the included angle between f1 and f2. The required direction between r and the first force. First force here is 3, so we write 3 plus 3 root 2 cosine 45 equal half. Using the calculator, we can find that measure of angle theta equals 26 degrees, 33 minutes, 54 seconds. Example 2. Find the magnitude and the direction of the resultant of f1 and f2 in each of the following cases. f1 equals 5 Newton, f2 equals 12 Newton, and the angle between their lines of action is 90. We have two perpendicular forces, f1 and f2. f1 equals f2 equals 16. Now in this case we have two equal forces. The measure of angle between their direction equals 120. Solution: since f1 and f2 are perpendicular, then measure of angle alpha equals 90, and sine alpha equal 1, cosine alpha equal 0. R equals square root of f1 plus f2. Again, r equals square root of f1 square plus f2 square. Don't forget, in the main rule we have here plus 2f1 f2 cosine alpha, but alpha equal 90 and cosine alpha equal 0. So we can use this rule directly. R equals square root of f1 square plus f2 square in the case when the two forces are perpendicular. The angle between them is 90. So we substitute r equals square root of 5 square plus 12 square, which equal 13 Newton. Let theta be the measure of the angle between r and the first force. Then tan theta equals f2 over f1. Again, theta is the measure of the angle between r and f1. Then tan theta equals f2 over f1. Tan theta equals 12 over 5. Then theta equals tan minus 1, 12 over 5. You can write it on your calculator. You get theta equals 67 degrees, 22 minutes, 49 seconds. And the inclination angle of R with the first force F1 equals 67 degrees, 22 minutes, 49 seconds. Second case, we have R equals, this is the main rule, square root of f1 square plus f2 square plus 2f1 f2 cosine alpha. R equals, by substitute you get R equal 16, and you can do it yourself. You have to solve everything and make sure you have understand every problem. Are inclined by an angle of measure 60 with the first force, actually with any of the two forces. because we have two forces, two equal forces. So the resultant R bisect the angle between them. The angle between them is 120, so we can write that R inclines by an angle of measure 60 degrees with the line of action of each force.